Okay, so we're going to talk about why do we see elements combine to form chemical compounds. So we need to make sure that we follow the law of octet. So that means every element needs 8 valence electrons with the exception of, yes, that's right, period 1, which is hydrogen and helium. They have 2. So we're trying to form chemical compounds to fill those valence electrons, or the electrons in the outermost energy level. In number 2, we're looking at a compare and contrast between ionic and covalent bonds. Remember, ionic bonds are between metals and nonmetals, or cations and anions. Cations are always positive, anions are always negative. And they will steal electrons from each other, and they form compounds or salts. Salts are usually three-dimensional solid spheres. They will have different geometric shapes to them, and they typically dissolve in water. However, there are some that are insoluble as well. In covalent compounds, these are nonmetals to nonmetals, which are both anions. They form what we call molecules, and they will share electrons. Remember, in covalent compounds, you'll sometimes see a positive or negative, especially with the polyatomics, and that's telling if you had electrons gained or lost from the outside. Both are trying to combine their electrons to fill the outer energy level. In number 3, you can see that we have the length of a single, a length of a double, and a length of the triple bond. Triple bonds, you can see, are the shortest of all of the covalent bonds, and triple bonds are hard to break. Nitrogen gas has 2 ends. They have 5 valence electrons, and it is a triple bond between them. Nitrogen gas is inert. It doesn't break down really easily, and so therefore it is easy to use for things like welding. And so triple bonds are the strongest, and they have the shortest bond length. For these, you can see that we have determined the number of valence electrons. And so what we've done here is sulfur has 6 valence electrons. Boron has 7. There's 2 of them. So we would take 2 times 7, give us 14. And then we have 20 valence electrons. And so those are pretty easy there. If we go down, we can see that we started with a number, or letter A, 5A. We have a central atom, and that central atom is oxygen. It has 6 valence electrons. The central atom will be the atom that has the most bonding spots available. Hydrogen is always a terminal atom, and the reason is because it only has 1 bonding spot. Halogens here will also be terminal atoms typically, unless we're breaking that rule of octet. But for this class, they'll always be terminal atoms. So atoms like silicon, carbon, those are going to be your central atoms, while hydrogen, chlorine, fluorine, those are going to be your terminal atoms. So we start by writing our central atom, giving it 6 valence electrons, and then we have a single bond to go to the hydrogen. In B, it's a little bit different. We do have our 6 valence electrons. We've bonded to each one of these, but we have a loss of the electron. The electron was actually located here, and it's been removed. And because we remove that, we signify that with a +1 charge in brackets. You can do the rest of those on your own. Just a little side note, if you have a +1, that means we lost 1 electron, where a -2 means we've gained 1 electron. After you create a single bond between atoms, what do you need to do if there aren't enough remaining electrons to compare? So the first thing that we're going to do when we do a single bond, like our CO2, so carbon dioxide, we have 4 electrons around carbon. Oxygen has 6. We would single bond them together. However, 2, 4, 6, 7 on each of the oxygen, and we only have 2, 4, 6 on the central atom there. So what we're going to do is we're going to take these, and we're going to move them here. Well, now this oxygen is full. 2, 4, 6, 8. The central atom now has 7, and the other oxygen has 7. So because we're still trying to fill that, we're going to move these electrons and put them here and connect them. So now we've double bonded. If we do not have a positive or negative charge, we cannot bring in anything to that. In number 7, what does it mean to have a resonance structure? Well, here's what we have. We are moving this double bond that we have could be formed on the oxygen. So we're just showing how it can be formed on this oxygen, or it can be formed on this oxygen. These would still have the correct number of valence electrons around them on each side. This is showing that what you can do is it doesn't matter what oxygen holds the double bond, and it can resonate through all of them. So all would be correct. In number 8, it's asking you to draw Lewis structures again. And so we'll walk through this first one here. We walked through a couple of these in class. So we erase and start over. So we want to start with our essential atom carbon. It has 4 valence electrons. We have 2 of them. The first step is to link them together. You'll notice that we have a hydrogen on each end, which signifies we should have a hydrogen located at the terminal side of both of those carbon. However, our carbon are no longer full. So we're going to take these electrons on the bottom, and we're going to bind them here. We'll do the same one more time, binding those electrons there. This would be a completed step for that. For your next one, it's carbon monoxide. 4, 1 oxygen with 6. We start by single bonding. We have not filled either one of the oxygen or carbon levels, so let's create another bond. Right there. Where our terminal atom is full, our central atom is not. So we need to fix that. So we're going to take one of these, and we're going to triple bond it. Notice we have an extra valence electron here on the oxygen. We're going to move that so that it is on the carbon. And so now both are full for this. So now we're going to walk through and see that you can do the rest of these there. E was already done for you. Remember, these are Lewis structures in number 9 for ionic compounds. So if we think about lithium, lithium has a +1 charge. It's also in group 1. So it has 1 valence electron, while oxygen has 6. We're going to single bond it. And we don't need to fill the outer energy level for lithium because it's giving its electron to oxygen, so its outer energy level is actually showing 2 valence electrons and is full. We just don't show it in the written one. So ionic compounds are a little bit different than covalent, but we did ionic last week. I hope that's helpful, and if you have any questions, please ask.